Hello, everyone, and welcome to another episode of AWS Bytes Live. And today, what we're going to do is basically going to continue our latest stream. But if this is the first time that you are watching this, my name is Luciano, and I'm joined by Owen. And
Hello.
what we do is basically we are trying to share our knowledge of AWS by different ways. Basically, in reality, we started as a podcast, so you can go and check out all the pre-recorded podcast episodes on our YouTube channel or on our awsbytes.com website. And we try to share a bunch of different concepts and ideas about AWS, all the things that you can do, all the services that you can use, and few other interesting details. In the last few episodes, so this is the fifth installment of our live stream. So in the last 5 episodes, we decided to try to do something a little bit different. We have been asked to show a little bit more what it takes to actually build something working, something like from scratch in AWS, especially using serverless, which is our main expertise. So what we did, we went off and we said, okay, we can do that, and we can start this kind of live streams. And we decided to build a file transfer application. So if you ever use something like Dropbox Transfer or WeTransfer, we are building something similar. So basically, a user can go into a platform, upload a file, get a URL, share this URL with somebody else, and they can use that URL to download the same file. And doesn't have to be between two different users. It's also something that you can use to exchange files between different devices yourself remotely, or maybe you have different devices and it's an easy way to just bring one file from one device to the other. And we decided to build all this stuff using AWS and serverless, so Lambda, API Gateway, S3. And if you have missed all the previous episodes, they are recorded and available on YouTube, so you can go and check them out. And today we are going to continue working on the authentication part. So we built all the APIs that allows us to upload a file, download it. We also built a CLI that makes all the process easier. And then at that point, everything was completely open. Anyone, just by knowing the URL, could upload new files, which of course is not secure. So now we are trying to add a level of security. So only people that are somehow authenticated are allowed to upload files, and we can decide who has an authentication or not. So at that point, we should be able to even deploy this thing in our own personal AWS account, and anyone can use it with some good level of security. So last time we were talking about the OAuth 2 device flow, because right now our only interface is a CLI application. So you generally use it by saying we share path of the file that triggers the upload, and the CLI returns back a URL. Now we want to add a layer of authentication. So basically that means that CLI application needs to have a step where we can say we share login. Somehow we need to provide credentials to our CLI, and then the CLI should be able to send the request to our endpoint with that authentication token, and then be able to upload the file. We decided to do all of that with Cognito and using this device flow, but I'm going to let Owen take over and explain the whole idea again and where we left it off last time. So I'm going to share your screen.
Okay, everybody. So we've got the repo, which is weshare.click. You can see the code exactly as we left it in the last stream here. So we've got a Cognito user pool and some other stuff in there you can have a look at. We're going to revisit that today and show everybody what we did and where we're going to continue this. Just to as a quick recap, what Luciano mentioned, we were looking at the OAuth 2 device flow. We have an architecture diagram in this repo. So we have the original architecture diagram for the MVP, which didn't include any authorization. And we also have this kind of sequence diagram showing how the OAuth 2 flow works with the device code flow and this classic authorization code flow and how they interact. So what we decided to do was use the features of Cognito, which allow you to do OAuth just as normal as you would do with any web application, and then just build a thin layer on top of it that does this device code flow specific part. So what's the device code flow? Quick recap. I have this video here I found on YouTube which describes how to sign into your smart TV with your Amazon Prime Video account. So you're probably familiar with this. That's exactly what we're going to do here. This is an example of the OAuth 2 device code flow. So you don't really have a keyboard that you can enter your password with. You're not really logged into your social accounts on your TV. So the way they try to improve the usability is by using this device code flow. And it's a pretty recent spec. I think it came out in around 2019. And it's designed to solve situations like this. Also logging into IoT devices like a smart plug or a smart light bulb and all that kind of really valuable stuff. And what it means is that you can log in on one device but complete the authentication process on your mobile phone or a tablet or something else, or even a laptop. So when you're sitting down, you want to log into your TV, you see that you have to go to amazon.com/mytv in this case and enter this code. And it just makes the whole login experience much easier for users. So even though we don't have a smart TV app yet for WeShare, we're just going to, because we have a CLI interface, we need to figure out how to authenticate with that CLI. We don't want to have people enter their usernames and passwords on the CLI and pass passwords over the wire. That doesn't really make sense. So that's Beck. Luciano's put it up, the link up on the screen there. The RFC 8628, that's what really solves this case for us, because it allows us to use a normal OAuth flow, but instead of doing a redirect back to a website, you store the state in a database. So what we did last time was we created the basic resources we need for Cognito, so the user pool, and that's where our usernames and passwords are going to live. And Cognito allows you to support then these standard OAuth flows. What we now need to do is just build on some additional layers. So I think there's 4 endpoints we need to build, and they're reasonably straightforward, but you'll have to pay a small bit of attention just to how the state changes from one interaction to the next. And the first one we started implementing just as we finished up the last time was the device authorization endpoint. So this is where it starts, and you've got an anonymous user comes along to your command line, installs the WeShare client, and they type WeShare login. So they're ready to log in so that they can start uploading files and share them with their friends. And the first thing we need to do is say, okay, we don't know who this person is, but let's start an anonymous session that we can later authenticate, and we can allow them to upload afterwards. So that's our first endpoint. Awesome. Did I miss anything there? Is there something else we should recap on, Luciano, before we go coding this one?
No, I think that's perfect. I'm just going to invite people joining the stream to just say hello in the chat. And if you have any questions, don't hesitate. We are here to try to answer the questions and to keep this as much interactive as possible.
Okay, great. So we've got a couple of things we need to sort out here. Let me just jump over to our code. This is our pseudocode for the device authorization endpoint that we were looking at the last time. So this is the device auth handler. This is our Lambda handler for the HTTP endpoint. We talked about the last time about how for this spec, for this RFC 8628, you need to create 2 codes. One which is like a high entropy device code. We chose 48 characters, and then you create a shorter user code. You saw from the screenshot of that smart TV example, they were using 6 characters. We're using 8 characters in this case. So we're going to generate that, and we are going to store it in a table so that we've got the state started there, and then we're going to construct that response. Okay.
So if I understand correctly, it's basically the device code. It's something that the user never has to input, and it needs to be harder to kind of brute force and guess. And univocally identifies that session that we just created, but it's not authenticated yet.
Mm-hmm.
The user code instead is what is the user itself is expected to input to kind of confirm that they are the ones that initiated that session. And at the same time, they can do that when they are already authenticated in the platform by some other means. That can be OAuth 2 username and password, or it can be federated login or something like that. I think we're going to be going for user pool, so that means username and password, right?
Yep, that's it. Username and password. Yeah. So for the response, we'll skip over the storing the entry in the table for now because we're going to need to create a DynamoDB table. Let's make that as to do. Maybe it is a good idea to create some metrics at this point, though. So we know how that works from the previous episodes. So we're using AWS Lambda Power Tools for TypeScript or JavaScript. And with that, we're just using MIDI to inject the Power Tools metric support. We have, I think was it episode 2 we introduced MIDI of this series?
Yes, or 2 or 3, I'm not sure. Yes, episode 2. Episode 3 we did the CLI.
Okay, so let's add a metric. I think it's a good idea to add metrics on how many of each of these endpoints is being invoked. We can see how many, you can use that to extrapolate how many successful flows you're seeing. Maybe it also might tell you if people without credentials are trying to log in, which is also useful information. So let's create a metric called device auth request count, because this is the device auth request. And we just need to specify the unit for that, which is a count, and the value, which is 1. We're just clocking one instance of that metric. Okay, so let's make this our response. Okay, so we're going to return a response payload. So our response payload, according to the spec, should have a number of properties. One of them is going to be exactly as we put in the comment last week, device code, and we know the value for that already because we created it. That's our high entropy, really hard to guess, really hard to brute force string. Then we've got a user code, which is the easier to guess, but very easy to enter on your other device without making a mistake. Then we need to put there's 2 properties. So there's verification URI, and this is generally the verification URI without the user code. So maybe that's never going to change. It's going to be the same for all users. So we're going to make that in a constant. And then we should also enter one that people don't need to, it has the code embedded in it. So if the user is on a device where they could scan, you could, on a smart TV, you could put in a QR code that would have the complete verification URI embedding the user code. Then they don't have to type anything on their smartphone. So let's make that rendition of the URL. So that's going to be with user code equals user code.
And we generated the user code not to have any URL special character, so should be safe to just do this kind of interpolation.
Yeah, I think so. I was just thinking that as I was typing it. Should we construct the URL and do it the right way? I don't know.
I think in this case should be safe
hard to
enough.
think in live code. Okay.
I think it's safe enough. I mean, it's more of a style choice, I guess.
Okay.
So I will leave it as it is for now.
Let's leave it as it is. Okay. So we need to specify to the user how long is this going to expire. So let's also make a constant for that expiry. And the spec says that should be in seconds. So use that in the name. And then you should also tell the client how frequently they can poll. Because once they start this request, they're going to have to poll the endpoint until their token is ultimately issued or denied. So we should tell them how frequently they should poll interval. So let's just make another constant for that, and we can maybe put a constants file together where we can share some of these across multiple modules, because some of these things will need to be reused elsewhere. So maybe what we can do is go back to our file browser and just create a new module, new node module, say called config.js. And in config.js, we'll just export some constants we might need. So what did we say? We're going to need the code, the expiry time, and the token request interval time. So if we say 2 seconds for our token request interval and 5 minutes for our code expiry. I think 5 minutes is plenty of time. You know, when people are logging in, by the time they see the code, they run to get their smartphone, trip over the dog, get up, get their smartphone, limp back to their laptop. It should all be possible within 5 minutes. Okay, so let's leave those there. And I think we can just import those now. So what are we importing? We're importing the code expiry seconds and request interval. Okay. Oh, we need a verification URI. So where does that come from? Well, let's put that in our...
Should it be an environment variable that we populate in some way, or do we just start code it?
I know that what we did for the other functions was that we had base URL. So we had, say, like this. We were taking base URL from process.env from an environment variable. Do you think it's okay to construct the verification URI then as a derivative of that?
I think so. Yeah, because ultimately we control the API gateway, right? The association between our custom domain and the specific API gateway, like the path where we mount that particular domain and this particular. Well, effectively, this is another stack, right? So we can consider that a kind of an independent app. So we will have, I don't know, probably /auth or something, right?
Yeah, I think that's the way we did it. Let's quickly look at the serverless.yaml from last time. So we created the auth service, and did we create any base path mapping yet? No, we didn't. So I think that's something we'll have to do. We're going to have to create a base path mapping. So let's see. I think maybe we can just flip over to that, change contexts briefly. It is something we've got in our backend service already. So the backend is where the actual file sharing logic lives. And in there, if we look, one of the resources there is API mapping. And that says that any requests that come into /share should be mapped to this API, the backend API. So we're going to do something similar for the auth serverless YAML.
Perfect. Yeah.
So we're going to create.
Sense.
Yeah. So I just copy pasted what we had in backend, and I'm just going to change the API mapping key for this one to auth. And if you haven't seen this before, it's going to be confusing because there's a couple of things referenced in here. So let's just maybe briefly describe what this is. So we've got in API Gateway, you've got custom domain. We put that in the domain stack, so you can check out what's in the domain stack on GitHub. In there's a custom domain, and we associated that with the domain name we registered, which is weshare.click. So what we're now doing is we're saying, okay, for this specific HTTP API, which is actually generated by the serverless framework, we want that one to be associated with that custom domain, but only for requests that have /auth in the start of the path. And the names of the resources generated by the serverless framework are HTTP API and HTTP API stage. So you just know that by looking at the serverless documentation.
Yeah, and just to summarize as well, another thing that we are doing, we have our upload and download APIs into another stack, and they will have a prefix path called /share. So this is also how we are able to route traffic across two different stacks by using this different prefix, and they will have two different instances of API gateway managing different APIs. And we didn't necessarily have to do it this way. We could have done everything under one path. But I think this feels a little bit nicer because all the authentication now is independent in its own stack, while the application code is somewhere else. So it feels a little bit more like proper microservices, I think.
I think so. Another option, I suppose, would be to use a subdomain. So you could use a subdomain for auth if you want. login.weshare.click or something. Okay, so we've got our auth, we've got our domain name. So we got that API mapping there. So if we go back to where we were trying to construct the verification URI, now we know that it will have /auth, and we can choose then the endpoint. And I think the one, it makes sense to choose something fairly short. So let's say verify. So now we've got a verification URI constant, which we can also import in the handler. And I think we have everything we need to return the payload we need in order to comply with that spec for the device auth request. Okay, so before we look at the table part of it, let's just return the HTTP response. So this is just a Lambda proxy response format. So the status code is going to be 200 because it's okay. We should specify the content type because this is JSON. And then we can specify our JSON response. With MIDI and some of the plugins or some of the middlewares that we have, is there I suppose a less of a boilerplatey way to do this, Luciano?
So there is a response formatter that can automatically, like if it sees that you are returning an object, it can automatically do all this wrapping.
Okay, nice.
I mean, considering that our project is still quite small, I don't mind a little bit of boilerplate right now.
Okay.
I think it's a little bit more explicit right now, but later on, if we see we are repeating this over and over, it might make sense to introduce the middleware.
Yeah, explicit is good. Okay, so we're going to have to create an entry in the table. Since we're here in the code, let's just assume we have the table, right? So let's create the code to do the put object in the table, and we can go back and add the table later. How does that sound?
Sounds good. And let me try to guess how this is going to work. So basically what we want to store is the association between the device code we just generated and the user code that we just generated. We're probably going to want some sort of timestamp because we also want to keep this thing limited in time, right? It doesn't have to exist forever in the database, or at least even if it exists forever, we need to know when it's not valid anymore because a certain amount of time has passed and we shouldn't consider it valid anymore. Is that correct?
Exactly. Yeah. Good shout on the timeout. We'll definitely need that. And we can also then use one of the features of DynamoDB, which is the time to live. So we can automatically delete them once that time has passed and not worry about having to do manual cleanup. I
know that there are some pitfalls there, but we'll talk about that when we get there.
Okay, great. Okay, so let's create some records then. So we want to store the device code, the user code. What is, rather than storing the current timestamp, in order to facilitate that ETL, we can store the expiration and calculate the expiration time. Is there anything else? The other thing we want to store is the state, because when users execute different parts of the flow, we want to check that the record is in the right state before they proceed to the next one. Otherwise, you might have state transitions that we don't really want to permit.
Like, for instance, if you log in twice with the same code, right?
Yeah.
You shouldn't
be
possible.
Sort of replay. Yeah, we want to prevent replays, I think, in general.
Sounds good.
Okay, so let's create our record. So we need the table name. So let's get our table name in. Maybe we can use that in our config, put that in our config.js as well. So that's something we usually inject as an environment variable. So let's make that an environment variable. Okay, so we have everything I think we need to store except for expiration and state. So let's say our expiration is going to be the current time, and then we're going to add on the code expiration. So we said that it's going to last for 5 seconds, which is our constant. Date.now is going to return
5
milliseconds.
minutes, right?
5 minutes. Yes.
Okay. You need to
5
stumble on the
minutes
dog
in
very, very
seconds.
quickly if you want to do it in 5 seconds.
Okay. Yeah. Thanks for clarifying that. I'm definitely going to make more mistakes like that. So we've got the code expiry in seconds, which is 5 minutes in seconds, 300 seconds. And we need to add that to the current time, but the current time is in milliseconds. So let's divide that by 1,000.
Okay. And in DynamoDB, is the TTL in seconds, right? I remember you
TTL
need to
in
provide.
DynamoDB is
Yeah.
in seconds.
Okay. I think you need to provide like a Unix timestamp, but I can never remember if it's milliseconds or seconds. It's good to know that
Yes.
it's seconds.
It is seconds as a decimal type. Yeah, so you can include your seconds component or your milliseconds component. I'm not sure if it honors those. I don't think so, because it's not accurate. I guess that's one of the pitfalls you were mentioning. It's not going to delete your record exactly after 5 minutes. It's going to be at least after 5 minutes. Is that right?
No, I think the documentation is even vaguer than that. It's like they say between 24 hours. Like in practice, I've always seen that being deleted fairly quickly, like in the order of seconds or minutes at most. But the documentation just says that it could take up to 24 hours to actually delete an expired key. And what they recommend to do if you want to be extremely strict is that when you query your record, you should add a condition that makes sure that the record doesn't have a timestamp that is basically the expiry time. So that condition allows you to kind of pretend that the record doesn't exist if the expiry is already gone over, but it wasn't deleted by Dynamo itself.
Yeah. So we're going
I
to
don't
do
know if we
something
will want
similar
to do
here.
all of that, but that's kind of the best practice if you really want to be strict about expiring. Well, not reading records that are potentially expired, but not deleted yet.
I know that there's a good bit of discussion out there, and I think Jan Shui and Michael Bayer and a few others on Twitter were discussing this topic. I can't remember exactly who was involved. This is going back maybe a couple of years. And a few people wrote blog posts on different strategies for doing event triggers on a schedule with serverless architectures, and comparing, event bridge schedules with DynamoDB and various other mechanisms. So it's I don't think there's a perfect way yet. Okay, so I think we have enough to create our records. So let's
we need to create a client, or do you want to just create a record?
We need to create a client. Let's create a client. Yeah. Okay. So we're using the SDK version 3. So what we need is the DynamoDB client, because everything is modular. So let's import what we need here. So we're going to need the DynamoDB client. Actually, we need to import that first. So the import is going to be from the client DynamoDB package. So it's AWS SDK client DynamoDB, which we added the last time. And the class we need is DynamoDB client. But there's just like in the SDK version 2, there's a document client wrapper that makes it easier. You don't have to deal with DynamoDB's serialization format, which can be very clunky to work with. So we're going to use the specific library for that, which is just called libDynamoDB. And the class you need there is the DynamoDB document. So we need to create that client and the library as well. So we'll do that outside the handler.
And
so
as
you
a
need to create the
reminder,
client.
this is a good practice, because that means that if you have multiple Lambda invocations in a short amount of time, probably the same Lambda is going to be reused. So that means that only the handler gets re-executed. So the client in that case is kind of like it's cached already. We don't end up recreating a client for every single request. So this is the same reason why we do tracing, logger, metrics all outside the handler code.
Yeah, exactly. Okay, so we got our client, and we're going to create a document client as a wrapper for that. So we'll call that doc client, and there's a kind of a factory method. Ooh, it's DynamoDB document.from the client. So now we have our document client. Okay, so we can use that to perform DynamoDB actions. So let's do we're going to do a put. So there's a number of operations in DynamoDB. For new objects or like an upsert operation, it's put. So let's create the record we want to put. So we're going to pass some input into this client. Okay, the input will need the table name, which we've already imported, and we'll then need the item. So the item will need to have a couple of properties. We need to understand what the key structure is of our document, of our database. And with DynamoDB, you define your primary key using either just a partition key, or you can use a partition key and a sort key. And that depends ultimately on how you want to access your data. Ultimately, having a partition key and a sort key is a good practice in general, I find, even if your access patterns are very simple like ours to begin with. So I'm going to basically reuse the sort key and the primary key and put the same value into each. So let's say our primary key is going to be based on the device code, right? So we can do a lookup if we know the device code. So let's call our partition key PK because it's nice and short, and when you're making requests to DynamoDB, everything is faster if your data is smaller, so every character counts. So that's going to be...
Meanwhile, we have David in the chat that is telling us to be more enthusiastic about DynamoDB. Thank you, David. We'll try our best. Let's get more enthusiasm.
Okay. I can ebb and flow between enthusiasm and despair for DynamoDB. Sorry, David. Okay, so maybe David is a big fan of single table design. Maybe he can let us know in the chat. And there's a bit of a debate about whether single table design is a good idea or a bad idea. But it's, regardless of what your opinion is, it's fairly popular. It's kind of here to stay. You don't have to use it. But I'm going to be open here, and I'm going to say let's allow single table design on this table, even though right now we're just going to store these very simple records. I'm going to structure things in such a way that we can facilitate single table design in the future. Right, so I'm going to be prepared for subsequent access patterns into the future. So what that means is that I'm going to make the table design really vague and very generic. And that might frustrate some people because some of the property names aren't going to make any sense logically, but maybe our future selves will thank me.
Yeah, this is one of those cases where I think it might make sense if you know DynamoDB to do a little bit of premature optimization, just because my experience with DynamoDB is that once you have the data in a table, if you want to change the structure of that table, it's like, yeah, good luck. There is no like migration system or stuff like that. You will need to do all the stuff on your own. And if you want to update existing records, it's also very tricky because you literally need to scan and update everything. So I think it's okay in this case to do a little bit of premature optimization just because the cost of change later will not be trivial.
Yeah. Yeah. Okay.
David is saying that he's still trying to digest single table design. So yeah. I think myself and yourself are in the same camp. I'm still trying to digest it as well.
We're all trying to digest it. There is a great book by Alex Dupree which helps, and but it's a practice, and I guess the main challenge with it is it's okay to design. Once you know your access patterns, you can do a single table design and you can implement a very optimal piece of software, but if you come back to it in 6 months, can you understand it is the main question for me.
Yeah,
maybe we can put that to the test here. Okay, so let's as an example of that, what I'm going to do, right, is when we store device code, I'm going to create a prefixed key. So rather than storing the device code as a raw value, I'm going to say device code hash and then the actual value of the device code. Oops.
And this is just a way to kind of differentiate different kind of records in the future. Right now, we are only going to have device code type of records, but in the future, we can use a different prefix to differentiate different types of records, right?
Yeah, exactly. Yeah, particularly, yeah, you could use it just to make sure there's never going to be any collision between records. You can also use it when you're using the sort key, so that second part of the primary key. You can then do things like begins with queries when you're querying, and so you can query based on your partition key, which is fixed. That's just a string in quality. But on your sort key, you can say begins with device code and then read all the device codes. But that could be, it could be something different, right? Your primary key could be customer ID, and then your sort key could be an order number, and then you could just find all the orders for a customer, for example, right? That's the kind of access pattern you could do. But I'm just basically going to say, let's make all our keys this syntax and hope that it helps with future proofing.
Meanwhile, I'm going to say hello to Italo in the chat. So good to have you here, Italo. I hope you're going to enjoy the stream, and feel free to ask any question.
Okay, great. So now that we have that device key, we're going to use that as the primary key and the sort key. So we're just overloading, right? We're duplicating here. Because we don't have complex access patterns. We could just, in our table, just use partition key. We're deciding to prematurely optimize. I hope it doesn't bite us. So that will allow us to do queries based on the device key. So if we have requests that come back for the device key, which I know we will have based on the device code, we will have that in the future, then we can do a lookup. But what about when the user comes in with their user code, right? They're an anonymous user, they go to their smartphone, they type in the user code. We need to do a lookup based on user code as well. So we need another key for the same row in the table that's going to be based on the user code. So what we can do for that is create another index on the table. We're going to create a second global secondary index. And because we're being vague about our table design, we're going to call that global secondary index GSI1. We don't give it a logical name because we're going to use it for potentially many access patterns into the future.
And also because different kind of records will potentially have a different value there, right? Is that the reason? Yeah, okay.
Yep, exactly, yeah. And GSIs are nice as well because they can be sparse. So even if you don't specify a value for these GSI, PK, and SK, they don't get stored in your global secondary index. So you actually save. It's actually an optimization in that case.
But for everything else, they copy the entire record, right? Like if you actually specify a value in the GSI, they will copy the entire record. Is that correct?
We'll get to that. You actually have options there. So we'll get to that when we look at the table design.
Nice.
The table code.
I'm really curious.
Okay, so we're going to do the same duplication. We're going to have a separate user code key. So let's make a user code key. And it's going to follow the same single table design-y fashion. Same pattern. User code key is going to be user underscore code hash and then the user code, the 8-character user code. So now we can do lookups based on device key, based on device code and user code. And then we should also store our expiration, of course. And we should also store a status.
Yes. So initially it's pending, right? Or do we call it something else?
Yeah, it's going to be pending. Yeah, exactly. Yeah, that's a good idea. So we can store a status of, say, pending in the in this. You've also noticed I called the state field S. I don't know why I did this. I had this designed to do this. We could also say expiration should be called E. The idea of using short character names is again just saving space in the record. What we could also do here, instead of having like strings all over the place, we're not using type safety here, but what we could do maybe just to make it easier is just create a
Like
constants
an enum,
module.
right? Yeah.
Yeah, an enum. So we could just do. Let's see, what's the best way to do an enum in this way?
I will just do like
just like an
variables,
object.
like pending.
Okay.
Like
Okay.
export them individually, like pending uppercase equal pending string and so on.
Okay. So let's maybe think about all the statuses here, so we can create a few of them. I mean, maybe this isn't the best way to do it, but we can have a constant for like the grouping for like the enum and then some values. I know they're not actually constants in this case, right? Because they're properties of an object.
Oh yeah, of course. But we're going to treat this dictionary as a collection of constants, basically.
Yeah. So we're going to have pending. Verified will be when they verified their code. I think we'll need also one for when their code is has been issued by the IDP. And also an error one. I don't know if we'll need any others, but let's leave that for now. Okay, so now we've got some statuses that we can reuse. So we're going to change this then to device auth status dot pending, and
Perfect.
that will give us some safety around that type. Okay. I think that's it, right? I think we can put this into our table. Maybe just for at this stage while we're debugging, we'll just log this, and we'll then run our put operation. So we'll capture the response in a variable as well, just so we can inspect it. So we're going to use the document client and call the put operation and pass put item input, and that will create a record. We might just log.
Just as a small comment, I don't know if it's good practice in production, of course, to log this kind of records. Maybe you would want to put something like logger.debug, assuming that in production you don't print debug logs. But right now, because we are building it, we just want to make sure it works. This is probably fine. But yeah, just keep that in mind.
Yeah. You know, in this case, we're dealing with authorization information and identifiers that identify a user session. I don't know if I'd like to log any of it. We don't at this stage have any personally identifiable information. I'll change it to debug anyway, and if we want to see the logs, we can just change the debug level.
Yeah, fair enough.
Okay, so we've got the. Maybe I'll just call this put item input. We'll see it. We'll be able to see it because we're logging the variable name. Okay. Then we've got the record. We've updated the count, and I think we're good to go. I think this, as far as our handler goes, that's everything we need.
Okay, so we just need now to create the DynamoDB table, right?
We need to create the table. Yeah, I'm just wondering what this. I have a new there where I shouldn't.
Oh, so that makes sense.
Squiggly line. Yeah,
that's a good catch by the Visual Studio Code.
Paste. All right, so we've got our table now to create. So this is where we have to create all our keys, and we could talk about global secondary indices and stuff, right? So let's create our table. This is going to be a DynamoDB table, of course. And the properties we need, first of all, we're going to talk about what attributes it has. So you need to add for every key, every field you're going to use in a key, you need to just declare the attributes and their types. So we're going to have a PK, which is our partition key, also called a hash type, and that's going to be type string. which you just need to specify uppercase S for that. And we're going to have a sort key, which is also a string. Now, we did say we're also going to have a global secondary index, which also has a partition key and a sort key. So let's add those. That was GSI1 and GSI2.
And they're both strings.
Both strings. And the wonderful revelation here is that we're going to need another global secondary index in the future, because if we go back to our diagram, at a certain, we'll notice that at an event, as part of the authentication flow, we'll go to our identity provider. They're going to call our reader. They're going to call our callback URL or redirect URL with this state property. And this state is like the CSRF token. It's another kind of one-time code that's going to be generated. That's another access pattern that we haven't implemented yet. So we're going to need another index for that. So we're going to call that, as you might have guessed, GSI2. And then those are our attribute definitions.
So we'll be using this in another Lambda, basically, when we implement that other step of the flow.
We're going to use all these. Yeah.
One comment I want to make is that people might have noticed that we don't have to specify every other field. For instance, we are not specifying the state, right? You only need to specify fields that are part of keys or indices.
Exactly.
And then in reality, when you create a new record, you can add as many properties, additional properties as you want.
Yeah,
and even in an inconsistent way, like one record might have 3 fields, another record might have 0 additional field, another record might have 20 different fields.
Yeah. In fact, if you declare fields that you don't use in keys in your table definition, it will also give you an error. So when you have your attribute definitions, then you can just specify, okay, which of these fields are my primary key, and that's in your key schema. So we know that the partition key, we have to specify, it's called PK. We have to tell DynamoDB that this is our partition key, and you do that by saying key type hash, which is another name for partition key. And then we can copy this for the secondary, for the sort key, and the key type for sort keys is range. So when you put a PK, or when you put a partition key value into a table, that decides which partition it goes into, and that ultimately designs the throughput for all of the records with the same partition. And that would be replicated across multiple instances, but you'll have like a fixed throughput for each partition for reads and writes. And then within that, you have a range of values that are going to be sorted in it's called a sort key. They're going to be sorted, and that way you can query them in order, and you can say, okay, I need all the records between this key, and it'll be able to extract them out really quickly, or it'll be able to say, give me all the fields that begin with this prefix. So that's our key schema. And then we can specify our global secondary indexes, which is something very similar. So we just specify GSI1, and for the GSI1, the attribute name for the partition key is GSI1PK, which is a hash, and the same for sort key. So we're basically just doing copy paste of what we did for the primary key. Interestingly, so we need to specify whether we're using provisioned or on-demand throughput. So for this, I think we could just go with something really small. Like we're going to have, let's just start off with one read capacity unit and one write capacity unit. I think you get 25 or something in the free tier. So it's really low. This is like one very small operation per second, but it'll do us for our demo. And
why don't we go with the manage one?
We can. We can, but I guess the only thing that you don't get then is deterministic costs,
Okay.
right? So your costs will. The great thing about it is that it will scale to zero. You won't pay if you don't have any interactions. But if people start hammering your authentication service, you could get some sort of a bill shock.
That's a good point. So this way we will be throttling logins rather than ending up paying more.
Yeah,
Okay.
it's a crude way of doing rate limiting at this
Yeah.
point.
Sounds good.
Okay, so that we've got that. You also need to specify your throughput for the GSIs. So let's do that. I'm indented far too much there. Okay, so I think this is our GSI with one exception. You need to specify which fields from the original record in the table are going to be projected into the index. So this is your question from before, Luciano. You can specify, are all fields copied into the GSI, or do you just want to pick the fields that are in the key, or do you want to specifically state which keys are included or which attributes are included? So this is a way of saving on storage cost in your GSI and performance.
Okay, I suppose if you store the minimum amount, like just the primary keys, then every time you try to read the fields, other fields through the GSI, DynamoDB will do a lookup using that primary key, and you are probably paying the cost of that lookup.
I'm afraid it's even worse than that, because when you do the read of the index, it won't be able to give you the fields that aren't in the index. It's just reading the index. You'll have to go and read the other fields yourself.
Oh, okay. So there is no automation there. You have to do it yourself. Okay, that's, I mean, yeah, a bit of extra work, but at least it's obvious what's happening behind the scene and what are you going to be paying for, or at least spending capacity for.
Yeah, exactly. Yeah. I mean, it comes back to this DynamoDB, almost the philosophy of DynamoDB. It provides you with almost a very raw storage model for databases. But if you want to achieve really high throughput performance scalability, it allows you to be very optimal about what you store, what you retrieve, and when you store and retrieve them. And all of the access patterns implemented well can be really super efficient. And that's why if you think about your projections carefully, you can store exactly what you need to read and nothing more.
Yeah, sometimes it reminds me of LevelDB. I don't know if anyone has ever used LevelDB with, at least I use it with Node.js, but it's, unless you add any plugin, like it's a very raw layer, like a key value storage, and every access pattern you need to think carefully exactly how to index the data so that you can actually find the records that you need to find. So, yeah. I think DynamoDB, of course, is a lot more than that because it's distributed, it's managed, and so on. But sometimes you find it, at least I find myself thinking in the same way as when I was using LevelDB locally as a simple data storage.
Okay, let's. For our purposes, we don't have a lot of fields here right now. I'm going to say project all fields. Okay, so we've got. I think we've got everything we need, but we did mention there's a couple of other things. Okay, I'm going to add in some boilerplate fields that I think are just good practice for DynamoDB. One is this one, point in time recovery. So this allows you to do backups from point in time. It's a good one to put on by default. And the other one is security, is server-side encryption. And I'm just going to enable that. Okay, so we've got encryption, we've got point-in-time recovery, we've declared our throughput, we've got a key, we've got two lovely indexes. But we talked about TTLs. I think our very last property to configure is about TTLs.
Yes.
So the property there is time to live specification. So with TTLs, you just need to specify what the attribute is that's going to tell you when to expire a record, and we call that expiration. And you need to say whether it's enabled or not.
Yeah, and interesting enough, it doesn't have to be an index.
Yeah. Yeah.
So I don't know what AWS does behind the scenes to keep track of all the records that are expired and delete them. But
I don't know, yeah. I know that they released a new version of the DynamoDB paper recently. I have it, I haven't read it yet. Maybe it's in there. Okay, we've got a table. So we've got our table, we've got this function. We want to make sure this function can write to it. So we might need some IAM.
Oh yeah, good point. I always forget about those until I see the error.
Yeah, that's taking the principle of least privilege to in its truest sense.
No, it's more that I forget.
Okay, fair enough. So let's add some IAM role statements using our IAM role statements per function plugin that we use in all our stacks. And we are going to allow, what do we need to allow? We just need put item, right?
For this Lambda, yes, that's the only thing we are doing, right?
Mm-hmm. Yeah. And resources, resource, right? Maybe you can do resources as well. And what we want to specify here then is the ARN of the table. So you can pick that out of the table's CloudFormation outputs using the CloudFormation get@, intrinsic function.
Because I suppose that if you do a ref, you just get the table name, right?
Yeah, you got it.
Yeah, that's probably worth of a certification question.
Yep. I don't know if it's in there. Okay. We also had in our config, we have an environment variable that we need for the table name, don't we?
So that's where we can use ref. Yeah.
Here we go. Okay.
Did we have other environment variables? We didn't, right? So that's everything in there.
So far, I think we're good. Yeah.
Cool.
So we have we already have log level debug.
Nice. Okay. Should we try deploying it and see what happens?
Yep. Let's do that. No, not in this directory. So I should be in
Auth, right?
And let me just check my identity. Okay, it's good. No identity crisis. All right. Okay. And here comes the cycle of YAML problems. Let's live debug YAML. Okay, so the error said I had bad indentation. Okay, so this is coming from the copy paste of the HTTP API, it looks like. And that's up at the top of our resources. Yeah, so this is off by 1.
Yeah, the joys of YAML again.
Yeah, I hear. There seems to be a lot of momentum around creating the next generation of configuration languages. So I don't know how long we'll be stuck with YAML for.
Ooh, errors.
Number of attributes in key schema does not exactly match number of attributes defined in attribute definitions.
Okay,
so
maybe we have a typo
that's a surprise
somewhere.
to me. PK, SK, GSI1 PK. SK,
oh,
PK,
I think
SK.
I know. Scroll a little
You see
bit.
it? Mm-hmm.
Do we need to specify the global secondary index for GSI2 as well?
Yeah, completely missed it. Thank you.
I like your Vim integration. Visual Studio Code. I would have
the
done
only way I know how.
Yeah, I would have done a multi-cursor there, but
I don't know how to use multi-cursors.
And I don't know how to use the substitution in Vue. I mean, I've used it, but every time I have to look it up.
Okay. Yeah. Yeah, I don't know if I can even use multi-cursors with the Vim plugin.
Did it fail again,
seems like
or was it?
It's cleaning up. It's still cleaning up the previous deployment. Yeah. It's still deleting something that we just created.
Okay, fair enough.
So perhaps the table.
Meanwhile, we can ask people in the chat if they prefer Vim or Visual Studio Code or something else, and start a flame war. This is usually where
everybody says Emacs.
Yeah, I hope so. So we get a good variety.
Ah, yeah. Sublime. Okay. I don't know why cleanup is still in progress. Maybe what I do is I have a Postman collection here ready to go. So what we can do is show people what this interface is going to look like. Mm-hmm. We don't have the client integration done yet. We're going to have to use some sort of API client, and
yeah, we will need to orchestrate all the steps manually. But I think it's a good way to understand the protocol, and then we'll build a CLI. Well, we'll build this authentication into our own CLI and do it in a little bit more of a automated fashion.
Mm-hmm. Yeah. So I'm gonna do that now. I'll just drag this over to a new desktop. Can I make this bigger is the question. Okay.
Should be readable to me. Let us know in the chat if it's not readable.
Yeah, so what we're gonna do is, this is quite straightforward, the first one. The first step is request device authorization. So this is posting to the endpoint we just implemented, and we don't need to pass any parameters. That's it.
Yeah, and it needs to be a post because the specification says it needs to be a post, most likely for security reason, because you cannot just put it in an iframe and trigger accidentally this kind of request.
Yeah, that's a good idea. So that's this part here. This part. Yeah. Okay, our rollback is complete. Thank you, CloudFormation.
Yeah, he's very keen in cleaning up stuff. There we can start our flame war of Terraform versus CloudFormation. Terraform would have been much faster, but I don't know if it really cleans up anything, so you might be left over in a weird state.
Yeah. I don't know what it needed to clean up. Certainly, I think one of the biggest improvements that could be made is making deployment faster, no matter what tool you're using. And, if it was cleaning up the table, maybe it should just kind of hide the table, because, I don't need to worry about that table really anymore. The failed version of the table, if that's what the problem was. Okay, so now it's creating everything again. So that table a table has already been created apparently. Let's have a look. Tables. This is called We Share Auth. We didn't specify a name for it, so it generated a unique name. So we got provision capacity. Time to live is enabled. We can look at the indexes. We've got GSI 1 and GSI 2. They look good. We can see what's projected. We can see we've got point in time recovery. We should also see in here that we've got encryption managed by AWS KMS. Yeah, so that's turned on. Okay, good. How's the rest of our stack coming along? It's done, it says. So let's give it a go. I'd be very surprised if we don't get an internal service error at this point, because there's quite a bit of code in this. But I think it's worth having a look. So let's hit our endpoint.
Okay.
As predicted.
Good prediction. Now let's try to debug.
Okay. So what maybe actually I think in previous episodes we went into the console, but let's have a look at how you can use the serverless framework to look at your logs. So
that's a good
you can
one.
just call SSLS logs -f for function, and then the name of the function, which I've just pasted from the serverless deploy output. Okay, we can see our...
It doesn't like the module config. Oh, you did
Aha.
not specify the extension?
I didn't specify the extension. Yep. So let's sort that out. I think this is a thing that relates to ESM modules. Is that right, Gianna? If you with the old way, you didn't need to have this, but with CommonJS models, you need to have the extension.
And by the way, this is a thing that drives people crazy between TypeScript and like regular JavaScript, because in TypeScript you can still avoid the extensions, because that extension is going to be either TS or JS depending at which phase of the code, whether it's already compiled or not. So they kind of figure it out. They will inject the extension for you. But it's something that can be very confusing if you switch between TypeScript and JavaScript. You need to remember that in JavaScript, you are forced to actually use the extension with ESM.
Yep. Okay.
And in CommonJS, you didn't have to. So that's another misleading thing why people are used not to specify the extension.
Okay, interesting. Okay, so I have to be extra careful about that from now on. Rather than deploy and run again, I'm just going to do a local invoke with serverless framework just to sanity check the problems like this. So we don't have unit tests for this right now. We're going a bit rogue. So I'm just going to call invoke local, and I don't even need to pass it anything. I don't need to pass it a payload because it's just a post request.
Right. Yeah, because we're not reading anything from the input, right? That's the reason. If we were reading anything from the event, we would need to pass an event with some data.
Yeah, I think you can do, like, in that case, you can do something like data
and formatted JS or a file, right? There is like...
Or a file, yeah. Like that, yeah. So it looks like in this case, it worked. It put something into our database and it gave us back a response, including a device code, user code, verification URI complete, which also looks decent, expiry, and interval. So I'm going to deploy that.
Awesome.
And look in our DynamoDB console just to see our record. So this new console. Okay, so there's our record. So let's click on the record and see how it looks in JSON format. So we can see our replication of data here. We've got our device code, partition key with this high entropy string. We've got the expiration. We've got the partition key, sort key, and the status pending. I think everything's as expected.
Yeah, now the next step will be to go into, of course, here we're not seeing the URL because we only return that in the API. We don't need to store it.
Yep.
But the next step will be to go to send the user somehow into that URL. So we should display that URL somewhere or do a redirect or whatever. And the user will continue there in a browser environment. But of course, right now we haven't implemented that endpoint. So if we do that right now, we should see like a 404. And that's probably the next thing we want to implement.
Good summary. Yeah, I think so. Yeah, we could go a few ways. We could start the client, or we could implement that. I'm happy to implement the the verify endpoint. Let's give this a whirl in Postman this time. Okay, so now in Postman, we're calling our device authorization flow first endpoint, and now we're getting back at 200 OK with all of these properties.
Mm-hmm.
Okay, let's click this URL. Okay, I won't click it, but I will copy and paste it. I don't know what happens if I click it. It'll probably try and load it, execute it as an API in Postman. So I'll do it here, and we get 404, not found. All right. I'm just going to add this as a commit so people can have a look in GitHub, and I'll call this implement or C8628 device authorization request. Okay, now our next one is the verify endpoint. We could also implement the token endpoint, of course, I suppose, because the next thing the client is going to do is pull, but maybe the user code endpoint is the verify endpoint is the next logical one because we just saw it. So what is this going to be? It's going to be another Lambda function, right, with a HTTP endpoint. So we can start in our serverless.yaml. Okay, so the first thing was create device authorization request. Our next function we can call verify. Request. So our handler will be, let's say, code verification handler, handle event, and we'll need some events again. So this case, because the user will be clicking on the link or just opening it on their smartphone, it has to be a get.
Mm-hmm.
And the path, I think we have to stick with what we put in the response, which is /verify. Do we know enough to be able to update our IAM? Let's give it a go. So we know that in this case, they'll be doing a verification. So we'll have to read the table to get, to do a lookup by user code, right? Because that's the only thing we'll have. So we're going to have to do a query, a DynamoDB query.
Do we also need to update the state at this phase?
Good call. Yeah. Actually, this query, before we do the state, let's do the state update. So that's going to be an update item. And we'll do another policy statement for the query because it's slightly different. We're going to, I think for this one, we need to put in a suffix. So we can use a CloudFormation sub and put in a wildcard at the end. And let's have a look at the documentation in the IAM documentation for that, just to explain what that is.
What CloudFormation sub does is basically it's like a string interpolation. So it's going to replace at deployment time, whatever is the value there into that string. So we're basically using the table ARN as a prefix, then /* would be the final string. Yep.
It's a good call there. So I'm going to trusty AWS actions, resources, and condition keys documentation. And in here, we'll go to DynamoDB and we'll search for the query action. And query is here. And what we need to specify here for the resource is either the table. So the table or the index. And the index is like table name /index name.
Okay.
So we can specify table or index here. So we could actually be very specific, but I think let's just put the wildcard for now. I think it's pretty okay to allow your function to read the table no matter which index it's using, and this is sufficient.
Yeah, also because right now we know that we are using only one type of records. I think that would make more sense maybe when you start to use different kinds of records. Maybe you want to limit the subset of data that your function can read, right?
Yes. Yeah. Completely. Yeah.
And you can probably do that with an additional condition, can you? Because with a single table design, you're still gonna call, I don't know, GSI 1 or 2.
Yep.
So you probably want to use other conditions to limit the subset of queryable items, like a prefix or something in the primary key,
Yeah.
right?
Well, when you query with a the index is almost like a different table, really. The thing is that it's just when you write to your table, the main feature of GSI really is that when you write to your table, your indexes get populated as well. But when you read, you have to specify which you're reading from. Are you reading from your table or are you reading from an index? And when you
Right.
read from your index, it's like almost like reading from a separate table. Because it's got a copy of the attributes, because we projected all the attributes onto it, and we have to read by the index name. So with an index, we're going to have to do a query on that. So it's not like when you're reading from the table, you can read a single value using the partition key and the sort key. With a global secondary index, you can have duplicates in your sort key. So you don't have the concept of a primary key, really. You just have your
Okay.
partition key and sort key. Because your indexes don't have to be unique, which is different to your main table. So that's why you can't do a get item with a partition key and a sort key on a global secondary index. You have to do a query. So even though
Right.
you're expecting to read one record, you're just going to do a query.
Yeah,
I hope we're
that's
talking enthusiastically enough about DynamoDB.
yeah, I don't know. It always feels you really need to think very hard on about how DynamoDB works to understand what you need to do, how to store the data, how to get the
Yeah.
data, which I don't know, coming from SQL, I think it feels like they already solved that problem like 30 years ago. So in a way, it's kind of nice because it feels you understand the database better, but on the other end, it feels like a lot more work than you should be doing.
Yeah,
But
I mean,
yeah.
it's true. I mean, they solved the problem of making a modeling system for data, which is relational, easy to reason about, and has a language that people can get behind and understand. And it's fairly ubiquitous. They created a scalability problem, I guess, it would be the response from a DynamoDB advocate. And with DynamoDB, you can scale from nothing to Amazon retail scale access. With SQL and relational databases, you really cannot get to that scale. So I I
Yeah,
would
or you
say,
need to
I mean,
start
of course, a lot of
breakdown.
people would say, sorry, Luciana, go ahead.
No, I was saying about, or I think SQL can scale up to very big levels as well, but at that point you are starting to break down all the advantages of SQL because you need to do your own sharding, query multiple databases, do all this kind of stuff where you're kind of losing more and more all the advantages of SQL. So
Yeah,
yeah, it's an interesting approach at that point.
yeah, yeah. And I think, like a lot of the DynamoDB designers would say, with a relational database, you just can't get to the scale of. Eventually, you'll run into limits, and you can't scale to what the design of DynamoDB gives you. But again, like the question comes back to for WeShare or other startups or line of business applications, do you need the scale that DynamoDB can give you? That's the other argument, and so it goes on.
Yeah, I would probably say that for this particular application, also given that it's like a little bit of a toy application, yes, we are trying to have conversation around how would we make this more and more production ready, but at the same time, we are not really running a business off of it, at least yet. So
Not
it's like
yet,
it's
no.
easier to try different things and not be too worried about the consequences. But I think the main advantage here is that because we are doing everything serverless, DynamoDB is just so much easier to provision than, for instance, having to start on our RDS instance and create users and tables there. like, yeah, it's so much faster to do it with DynamoDB than with RDS in terms of just provisioning the infrastructure.
Yeah, that is true. And if you're just storing non-relational data, it's quite simple, and you don't have to worry about all this single table nonsense that I've introduced.
Yeah, we could have kept it a little bit simpler, but it was nice to see all of that stuff as well.
All right.
By the way, you can tell that I'm coming from a few days of playing with RDS, and I'm exhausted by the amount of work that there is from an infrastructure perspective.
Yeah, well, then you're thinking about multi-AZ and read replicas and authorization and all that fun stuff. Instance sizing as well.
Yeah.
That long forgotten topic. Okay, so while we were discussing debating the pros and cons of DynamoDB with ourselves there, I just pasted in some of the boilerplate that we have for all our handlers, and this is going to be for our get function. So let's get cracking. For our function, we know that we take a query parameter. We've got that in our verification URI complete. So let's pull that out from the event. So this is called user code. We're going to extract that from the query string parameters. And because it's using snake case, I'm going to use rename that property to use camel case. So that we'll pull out the user code with an underscore, and we'll end up with the property user code camel case. Okay, so then we're going to need to do a lookup on our table to validate this key. So we need to do a lookup, and what we also need to think about every time we do an interaction is, has this authorization expired or not? So we can use DynamoDB to query that. So let's see what that might look like. So we need to create our key, and we already have a key for the user code key from before, which has the user code prefix. So that's what we can use to do our lookup. We should also do a metric, right? Just like we did for the other one.
Oh, good point. Yes. Yeah.
So let's call this verification attempt count. When I'm doing metrics, I like to put the unit or the metric type, the unit essentially, at the end, so I can see when I'm searching metrics what they are. So I know that a count metric is a count, and if I log time, I like to put time at the end of it.
It's a good practice, I think, because sometimes it's very confusing how you should use all the aggregation formulas. And yeah, depending what's the unit, you might end up with very misleading results.
Yeah. Okay, so we're going to query on user code. Where did we store user code? Do you remember?
We did store the user code. Was it in the primary key or was it in an index?
Let's check. This is one of the joys of single table design. You have to check the code to find out, or the documentation, which may or may not be up to date.
Or may not exist.
The user code goes into GSI1 PK.
Okay.
Maybe we should have had a prize for whoever could guess it. Anyway. We're going to run a query. So our query input is also going to have a table name, just like the last one. Oops. That's not what it's going to look like. That's the value. I pressed a button and VS Code did something unexpected. Table name.
You have a typo there. Table tame, which is a great name. But...
Thank you. It's getting a little bit late. Okay, so we have our table name, but now we're querying an index, so we need to put in the index name as well, which is GSI1. And what are we going to query on? Well, we're going to query on the key. So for that, we can use a key condition expression. And this has its own syntax. It's like it's almost like a SQL wire clause. But what we're going to say is because we used both keys, we're going to have to compare both. So we need to specify the GSI1 PK is some value and the GSI1 SK is also some value. And the way to do that here is you can sometimes put the literals in here, but it tends to result in all sorts of problems. So what you can do instead is put in these placeholders. And this, if you prefix them, these placeholders with a colon, then DynamoDB will identify these as expression attributes. And then you in a separate property, you specify what these expression attributes actually refer to. So what the value is.
This is similar to prepared statements in SQL stuff, and it's pretty much a way to avoid injections, right? Because these are user-provided fields or values. So it's better to make sure that they are properly escaped and sanitized by the database before they run as a query.
The other, exactly. The other thing is that there are some reserved words. So if you try to put certain strings in here, they're actually reserved in the language, and there's quite a lot of reserved words. So your query might just fail on that as well. Okay, so then you can specify what is the value for that, and that's going to be our user code key. So this is a bit like saying select star from our table, where the user code key is this value. And that's going to give us back one or more values, or zero or more values. So let's run that query. That would be query response is, we need to do our doc client again, and this time it's going to be a query with our query input. And let's, for consistency, also log the input and the response.
By the way, I have a generic comment meanwhile that, and just to kind of note that here we are doing everything in a very kind of manual, explicit way. We are not doing any like ORM-like practice, if we want to call it like that. Like we are not creating DTOs or objects to kind of read and fetch the data, repositories, all these kind of patterns that you might have seen in more kind of enterprise projects. It's not because we cannot do that. Of course, we could have done that. It's more that here the code is simple enough. And again, we're just trying to be as explicit as possible. But if this particular stack were to grow a lot more, probably would make sense to try to refactor things and avoid duplication. For instance, one obvious duplication is line 20, where we are reconstructing that unique key. Maybe we could have used a function from a specific user code object to create that automatically from the actual user code value. But here it's just simple enough to duplicate a little bit the code.
Yeah. This is a fair point. I think it's good to be explicit for sure in this case. So we may have a value at this point. So how do we find out if we have a value? Well, if we have a value, then it's going to come back in DDB query response.items. We can see already this is an option. This may or may not be there, right? So what do we do if there's no value back? What are we going to say to the user? If we don't find your user code in the database, what should we do?
I think this is an error, right? So we should just say that it's an invalid request in some way. I'm not really sure if the spec gives us default errors for these particular cases. But I mean, it's definitely an error. It means that you started the second step of the flow either without having done the first step, or the first step was expired already.
Exactly. Yeah, that's a good point. Yep. So what we can do then is we can return like status code. I think 400 is what is required. But remember, this is the web request. This is basically just providing response back to the user.
Mm-hmm.
In fact, there's a couple of cases where we'll need to provide response back to the user. So I'm going to create a little JavaScript front end framework. Maybe not.
A new
maybe
framework.
Not so lofty. I'm just going to create a helper function which will allow us to create a response with a status code and some text and render it as HTML. So what would that be? We need to return in Lambda, we need to return the status code, and we might return the body. And the body is going to be some HTML. So we could just do like this.
Sorry if I stop you for a second, but I don't see your screen updating anymore for some reason.
Oh, no.
Maybe you can try to stop sharing and share again.
Okay. Let me do that, yeah. I can see it in the other screen, but let's do that. I'm sharing again now.
Awesome. Okay, now I can see the HTML. For me, it was stuck at the previous file.
Ah, okay. So we've got our status code, we've got our rendered content, and we can also specify the content type then.
Mm-hmm.
This is the crudest possible way.
I like it. Only one suggestion: export default function, I guess, or export function, and then we import it with the name. Yeah.
Perfect. Thank you. Okay, so now instead of this, we can use my helper function. And we can say, what should we tell the user?
Invalid code, I suppose, is the easiest.
Yep, sounds good. Maybe, yep.
And again, maybe we can check maybe we can check the RFC if there was any, I don't know, best practice or default message that you can use in these cases.
Yeah, I don't recall any, but yeah, it might be good. Might be a good shout. Okay, so now at this point we can update our record, I think. So if that hasn't happened, then we can assume that we got a value back. So we can then extract the other fields out. So we know that there should be one item, and then we can pull out the PK and the SK, which would be the device code.
Mm-hmm.
And then at this point, we're going to start.
I have a question that
Yes.
maybe it's hard to do for later. I don't know if we need to do anything like right now. Let's say that we were able to get the record, but the record is just expired before AWS had a chance to actually clean it up from the database. Is it a best practice now to double check that expiry field is still within boundaries before we proceed?
Yes.
Just because AWS doesn't give you this kind of atomic guarantee that as soon as a record is expired, you're not going to be able to query it anymore. You might still be able to query it for an undefined period of time between 1 second and 24 hours.
Yep. Yep. So there's a couple of ways we could have done that. So we could do a separate check, a separate query to do that. We could have put a condition into our original query.
Does that mean that we need to explicitly propagate that field into the index?
Yes, but we did project all fields, so that should be okay. But because we're going to make an update in the next one, so what I was thinking here is we could do a bit of a trick when we update the state. We could put the condition in the update. and it would stop the record from being updated if the code has expired.
Okay.
So the reason for that, I suppose, is that, well,
For me, we can even just put a to-do for now and just do it in another time, because that's a little bit of complexity and it's a bit of an edge case. But I think it's worth calling that out as something.
Oh, yeah. I mean, it is. In order to be compliant in the spec, you should be accurate in the expiration, right? So it's definitely worth getting right. So in this verification, this handler is actually one of the more involved ones, because it means the user has clicked on it. We're going to have to start the actual OAuth 2 normal auth code flow here. So we're going to have to start talking about if redirecting them into Cognito and letting them sign up. So before we do that, we need to generate this other CSRF token, the state. It's called state, that we need to pass into Cognito. We're going to have to store that in the database in our GSI2. So let's get started on that process.
Right.
So we've got the device code, which is good, and then we got the state code, right? So the state code is, it's going to be another random string. So we can use our crypto random string function as we used before. And I think it should also be URL safe. Same as before, we can create a key to store that in DynamoDB following the same syntax. And then we can make an update to store that in DynamoDB. So let's make an update. We're going to call an update item. So let's create some input for that with the table name. And we need to specify the key, because we're doing an update. You have to specify the primary key, which is the partition key and the sort key we've already pulled out of the previous response. And then we're going to specify what we want to update. And our expression here is just going to be like the key condition expression above. So we're going to say, let's set some values. Yeah,
this is again the DynamoDB query syntax. So if you haven't seen DynamoDB before, don't worry. That's just the specific syntax for this particular database. As if you were using MongoDB, there would have been another syntax to do queries and updates.
Yeah. So we should add the state key, but we should also update our other state field, the S1, which I'm going to call, because we've got state now, it's a bit confusing. So I'm just going to call that status. And we're going to specify that as a new status value. Okay, so I think those are the things we need to set. And previously we had expression attribute values. Now we've also got expression attribute names. So in here we have the colon prefix. In here you've got the hash or pound prefix. Expression attribute names. So our expression attribute names status is going to refer to that field S, which we had before.
So the pound is basically to identify a field in the query that is not primary, an index key or a primary key or sort key, right?
Yes. Yeah. Again, you can use the literal value there, but sometimes you run into collisions with reserved keywords. So
I see. Okay, so it's like in MySQL when you have to use the backticks as a extra safe measure to avoid edge cases.
Yeah, that's it. Okay, so we need to specify some new values. So I think we've got new status. So we need a new status value. So at this point, it will be verified. What else do we need to do? Oh yeah, we also need to specify the state key value. And that's going to be state key.
I think you have a typo there, stats key.
Thank you. Yeah. What I was suggesting as well, and we can throw this in there quickly, is that we can put in a quick condition expression. And the condition expression will prevent any update if the condition isn't met. So I'm going to say, don't update if the status isn't what we expect it to be. So if you're trying to make an invalid state transition. And
I like that.
we can also do the expiry time. So now we can actually validate that the expiry hasn't been triggered yet. But because we've got that, we need to put some more values in our expression attribute values. So we need to put in the previous status that we expect. The previous status we expect is pending, right? It should have been pending before it's verified. And the expiry time.
I honestly expected that there was a configuration field called something like condition expression attribute values. But yeah, I suppose if you have collisions, you can use different names between the two expressions.
Exactly. Yeah, you can. Yeah, that's true. And when does it expire? It's going to expire. The expiry is going to be, let's call this expiry time, and we'll create a property for it. So we should probably do it when the request comes in, because that's a fair time. And that's going to be now divided by 1,000 plus the expiry time in seconds. Right, yeah, that seems to make sense, I think. And that's it. So we're going to do an update then, DynamoDB update.
Yes. So what happens if the update fails? It means that one of the conditions failed. So we can, again, give an error to the user.
Exactly. So we need to catch exceptions here. So when we get an error, we can check the specific type of code that comes through. So if our error is as a result of condition failed, what is it? I have it here. Condition check failed exception. That will tell us that this failed.
Is it condition or conditional?
Let me look at this carefully. It's condition. Ooh.
Okay, interesting.
It's conditional check failed exception, yeah.
Okay, that's good. Good memory. I would have guessed for
no,
condition.
that's not memory. I'm Googling on the other window. And I had a reference. Yeah, once you said it, I presumed it was a typo that I've copy pasted, but it is conditional. Okay, and in that case, we assume. Okay, what are we going to assume? Either of these failed. I think we just need to tell the user something failed. So I think we can we'll assume that they're a good actor, and we could say the token is expired. Yeah, we could say the token is expired or already verified.
Mm-hmm.
Okay,
that's fair. I think that's a good message.
Okay, and then otherwise we'll say, oops.
Something wrong happened, try again.
Maybe what we can do is put in the request ID from the Lambda. So at least if they come to us and tell us,
oh yeah,
I got this message, we could trace it through to the logs. So we can go to the AWS. We can take the AWS request ID
That's a very good idea.
Out of the context, which comes in here. It's the second argument. And this request ID, because we're using the PowerTools logger, it's going to be logged in every line, which is something really nice.
So we could pull all the logs from CloudWatch logs inside for that particular request and see if there was something suspicious.
Yep. Exactly. Yeah. So I think the last thing we need to do is a happy path. So we need to redirect them to the IDP to log in. So at this point, we're saying, okay, they've got a legitimate user code. We're going to create another code that they can then use to proceed to the next part of the flow, which is the device code flow. Sorry, not the device code flow, the authorization code flow. And that's going to redirect them into their IDP, which could be Google or Facebook. In our case, it's Cognito user pools. So let's create a redirect, a URL to redirect them to. So let's call this destination URL. Now the URL for this, the base URL for this will come from Cognito. And I don't know if we put this into our environment variables before. Let's have a look.
Yeah, I don't remember that.
Yeah. Yeah, I think we need to create a new one.
Basically, what we're trying to do is to make sure that we redirect the user to the Cognito UI that handles username and password input.
Yeah.
Or, I mean, there is also a chance that they are already authenticated in that system and it will just transparently follow all the redirects, right? But at that point, we just end it off to Cognito and say, continue from there, and Cognito authentication should have everything we need to complete the authentication.
Yeah. Yeah. And hopefully we can see that in a second. So I think what we need for this is we created a user pool domain, which is like this prefix that we can use in the Cognito. We also created a client. So let's pull the client ID and the user pool domain in as environment variables. And then we can construct the URL based on that. So let's construct a URL called Cognito OAuth base URI. So that has a known published prefix syntax in the documentation. And it starts with your prefix, your domain prefix, and then it's .auth, and then it's .your region, which we can also pull in from environment variables.
By default, every Lambda has that, right? Or do you need to explicitly?
Exactly,
yeah.
Then
Is it also in the
Amazon.
context? It might be in the context.
I think it is.
Well.
Yeah. So that's your domain, and then the next part is OAuth 2. So that's the base URI for your Cognito URL. I think that's correct. And then within that, you'll have the two subpaths. One is the one for getting the code, because this is the code flow. You need to go to two URLs, and that's going to be that base URL /code. No, sorry, /authorize. So that's the one that returns the code. And then the next one we need to have is the one to get the token. Which is /token.
Makes sense.
So that's our URL. Now we can use that to do the redirect. I think we just need to make sure that we've got all these environment variables in our code. So we need to make sure we have user pool domain client ID in serverless.yaml for auth. So let's go up to our environment variables. Okay, we do have them, it looks like. We've got client ID and user pool domain. Cool. So let's have jump back to our code verification handler. Now we can construct. We've got Cognito OAuth code URI here. So this is going to be code URI. This is our destination, and we can redirect to that. So we need a whole bunch of query parameters for this to work.
Right.
So we need to say that this is a code request. So for that, we need to specify, this is all in the other spec. So that's RFC 6479, I think.
I'm gonna double check that.
I was wrong, 6749. So we're now down to here, right? This part.
Yeah, OAuth too.
Auth to authorization code flow. So we're going to do a get on there. Sorry, we're going to do the redirect to the IDP URL. It's this part here. Yeah, the redirect URI and state. And that's going to redirect to Cognito. So this is the part of the flow we are concerned with right now. So we need to pass in redirect URI state, but we also need response type. So that's going to be code. What's the next field we need? We need to specify our client ID. And that is something that we don't have to show to the user. We need to specify what the redirect URI is.
Well, the user, if they want, they can see that in the URL, but it's not something that they need to manually like read and understand and use it. It's just part of the communication.
Yeah, true. So we need to create a redirect URI. Now, I've already copied that in the boilerplate, but I don't think we put that into our config.js yet. So what should our redirect URI be? And that's
for us to decide, right?
Because it's for us to decide. Yeah. We have verification URI, so we can just call it callback.
And I suppose, considering we are going to be using this from the CLI, it's not like a web app. That URL will probably only contain a simple message like, okay, authentication completed, now close this window and go back to your CLI. Right?
Yep. Exactly. It's going to be the simplest user interface ever. Okay, so we've got our redirect URI. What else do we need? Oh, of course, we generated a state property. The whole point of doing that was so that we could send this token through. And this is the thing that's going to be between us and the IDP. Now, yeah, you're right, the user will see it, but this is going to be a state that's used just for this part of the state transition. It's a key that's used for this part of the transition.
Yeah, it's like tracking a session that basically tracks the exchange between our auth device flow and the Cognito authentication flow, right?
Yeah, that's a good way of putting it. Yeah. The last one here is we should specify the scope again, which is OpenID. So this is an OIDC code request. I think these are all the fields we need. So then we can redirect. So we redirect with status code 302. And for a 302, which is a redirect response, we need to specify the location header.
Can you create custom scopes with Cognito? I think so, right?
Yes.
So maybe in a future version, we could create like an upload scope to even say, okay, I'm logging in, but I expect the user to be able to perform the upload operation, right?
Yeah.
With OpenID, we just get basically the OpenID, what is it called? Token? User token or identity token, something like that, which gives us all the information about the user, no name, email, things like that.
Yeah. Okay. So right now I think we've got everything. We should be able to deploy this.
Yeah, I suggest we try to complete this one and
But
then
we
we
need
call
to
it a
export
day
that function.
because you have been coding for like 2 hours, and I
So
think
let's copy our typical boilerplate for that part. Everything else looks good. So let's try to deploy.
YAML errors.
I switched audio devices just now.
Okay.
I had a battery run out on my other headphones. So I don't know if you were talking to me for the last 30 seconds or not.
No, I was just saying that you have been coding already for 2 hours. So that's if we make this work, that's probably more than enough for today.
Definitely. Okay. Okay, we've got some errors here. So I think we've got a problem with our events. It's saying unrecognized property path here. And then serverless framework is saying we've got something that isn't iterable. So I think we've got a very basic error in our serverless.yaml.
Some more indentation issue.
Oh, okay, we've got events, HTTPI get. Okay. Yeah, definitely too late. Just a bit of indentation.
I can do these errors even early in the morning.
Oh, me too. If things are working more or less as we expect here, we would expect that even with the previous URL we got with the user code from before, from our first device authorization request, that we could put this into a browser and now it should tell us that it's expired, right? Because this was much longer than 5 minutes ago.
Mm-hmm. And you still have that URL in Postman, or do we?
I still have it in
Or
Postman.
in the browser? Okay, cool.
Yeah,
I'm glad that you saved it somewhere.
Yeah, Postman has all sorts of secrets. Tokens. Okay. What is it taking so long? Creating this new Lambda function. It's a big one. Okay, we're nearly there. The function's there. Creating the HTTP API, that's done. Creating a route. It's nearly there.
A small rant about serverless framework compared to SAM. In SAM, they actually integrated a nice visualization that looks like this screen here, so you can actually see which resources are being provisioned and what's the status of each, rather than just random dots that you cannot really tell what's going on.
Yeah, and this should now be possible in serverless framework because I know SAM uses CloudFormation change sets, which allows you to track these things. Well, I suppose you could do that anyway in serverless framework, but now both the serverless framework is also using change sets now, from what I understand, and it should be possible to give you beforehand a nice plan of what it's about to do and also track the status. Okay, let's have a go at our. Oh, we've got the URL open already here, so let's refresh it. Okay, internal server error.
Okay, so we probably have a bug. Let's use our serverless logs.
Okay. What did we forget? Ooh, an expression attribute value used in the expression is not defined. User code key.
Maybe a typo.
Okay, so we've got user code key. So do I have just a basic error here in the... Yes. So this should be expression attribute values.
Okay. I did expect the typo to be in the keys of the expression itself, but no, it was actually in the configuration object.
Yep. It's okay in this one. We have it right in the second example. Okay, so then let's do the thing we did before and use serverless invoke local just to make this process easier. But this time we have to pass in data,
And you need to
our
query
data will
string
need,
parameter.
yeah, and that will need user code, which will need to have a value.
You can
And the
probably just
value,
use any random value right now, right? Oh yeah,
That's
let's
true.
take this one and see if it gives us the expired one.
Okay. Now we've got another
Cool.
one, which is in the next one at least, but it's saying that we're missing GSI1PK.
Okay.
We actually forgot to put our GSI1PK in our query, did we?
Different error is progress. We did. Wait, was it GSI 1 or 2 that was complaining about?
GSI1, it's up here.
Okay.
Right. But we do have that there. Oh, GS1, GSI1. So we were searching on GS1 PK, which
Right,
doesn't
okay.
exist. Small typo. Okay. Invalid code. Maybe it expired.
Expired. Perfect. That's what we
Excellent.
expected. And if you try another random code, you should get the same because it's pretty much trying to
Yep.
guess a code.
Yep.
Yeah. Okay.
Same one. Okay, shall we try with a new code?
Yes.
Okay.
So
Okay,
we get
we
a
have
new code
freshly
there.
baked code. Okay, now we have another error. So again, that's progress. And it's something went wrong with request ID.
Oh,
So
do
at
we
least that
log the error in some shape?
we should see it. I think serverless framework. Well, oh, good
Because we
point.
have our try catch, but then I don't think we ever logged the error.
Good shout.
Do we?
Okay. I don't think so. Catch error. Okay, so let's log logger.error. So it's not a conditional check failed. So I guess it's just another DynamoDB problem. Okay, now we've got an expression attribute name used in the document path is not defined. Exp. Okay, so we just missed something. Oh yeah, we said exp. So we need to put in expiration.
Oh yeah, that makes sense.
Attribute name. Okay. And now we have a 302 redirect.
Okay, and we can open this one, right? And we should see the login screen for Cognito. Should we?
Let's give it a try. Oops. There we go.
Nice. Okay. So technically you could finish the login here and then end up in the callback, but then that callback is going to be a 404 because we haven't implemented it yet.
Yes.
Also,
exactly. We don't have any users.
Oh yeah, we did create a user. I think you created a user for me. Last time I never confirmed my email, so I don't know if it expires after a while. But I think we tried to insert one user, yeah.
Email verified. Okay, great. Can I manually? Okay, I can mark it as verified, but you need to change your password, I think, anyway.
Yes. So let's. I think we can leave it for next time. But
we can leave it for next time.
The flow at this point is that as a user completes the login, at that point we end up in the callback URI, which we haven't created yet. But that callback URI will get a code, if I remember correctly, in the query string parameter. So once we implement that particular endpoint, we can use that code and exchange it for a token.
Yeah.
And at that point, Yeah, we can basically tell the user close the session and close the window and continue in the CLI, and the CLI will be polling. So we will also need to implement that polling mechanism, right?
The polling will be quite straightforward. I think the only difference from the way you described it is that what we might do is, instead of when we get the code, we don't have to get the token at that point. We could store the code and then just get the token on demand when they do the poll.
Right, that's fair. Yeah.
That means, because actually the endpoints are actually really similar. The polling endpoint that they're calling all the time, and the one where we make the request to Cognito, they're almost exactly the same with some variations. It's just like a slight change in the spec between one RFC and the other. So it will be quite easy to do that. And then we don't have to store the token, which is the highly valued secret. We don't have to store that in the database. It's just
that's fair.
Transitory.
Yeah, and at the same time, if the user already closed the CLI, like we are not even issuing the request to get the token, right?
Yeah, exactly. Yeah, it never comes.
Cool. That was pretty good. Thank you for spending all these energies in coding all this stuff. Okay.
Thanks to everybody for enduring our DynamoDB efforts today. I forgot how long that would take.
Our DynamoDB madness. Yeah, the query language always scares me a little bit because I don't think I've used it enough to be used to it. And it's of course a little bit bespoke, right? It's you wouldn't see something like that in other databases. So it's unique to DynamoDB. It takes a little bit of time to get used to it.
Yeah, it's powerful. It's not immediately intuitive or developer friendly, I'd say, to be sure.
Okay, so should we wrap it up here, or do you have any other final remark?
I'll commit and push these changes, and I think we've got the bulk of the logic definitely implemented. The last step will be a lot easier because we've got all the resources we need now. We just have to implement the last two state transitions, so that's going to be pretty quick. And then I think the really fun stuff will start when we are able to protect our API and then integrate the front end, the client, and figure out how do you do that with Node.js client. I'm looking forward to that.
Exactly. So what we are going to be seeing next time is completing this callback endpoint, and then I suppose at that point we can just simulate everything else from Postman. And then when we start to build the CLI, we will kind of do everything that we have been doing with Postman, but this time we're going to be automating all of that with something that we're probably going to call WeShare space login in our CLI. And that is going to guide us through all the steps. Open the browser, insert credentials, do the polling behind the scenes, and eventually it's going to tell us, cool, you are now authenticated, you can go back and upload using, and behind the scenes, our CLI is going to know how to store these secrets and use them as necessary. There is one more thing we will be doing, which you mentioned already, so sorry if I'm repeating, but it's actually in our API gateway, we will need to add some authorizer to actually make sure that our API is not open anymore, but it's going to actually make sure it's going to need to include the credentials that we are just kind of making available through all this process. Okay, so yeah, it's getting late here, and you can probably tell we are getting tired. So I'm gonna stop ranting. Just make sure to follow us, subscribe, give us thumbs up, comment, share, everything, the usual stuff. And we'll be announcing the next live stream probably next week. But yeah, stay tuned for more, and we'll be updating you. Thank you very much, and until next time, take care. Bye.